Hello everyone, welcome to my channel on learning field. Today in this topic I will teach you how to find the electric field due to an electric dipole at a point on the axial line. First of all, we need to draw the diagram for this. Let us draw the diagram. This one is E1, this one is E2 and this one is C. Let this point be A and this point be B. This is minus Q charge, this is plus Q charge, and the distance between these two is the distance between from A to B is twice D, and this point is known as origin, and the distance between A to O is also known as D, and the distance between O to B is also D. So D plus D is equals to twice D. The distance between O to C, O to C is R. So let us write the expression for this. This is a special case. If the point P is far away. If the point P, where is the point P? Suppose this is the point P. If the point P is far away from the dipole, then we can write D is very small than R. Remember that. Then we can write E is equals to Q by 4 pi epsilon naught into 4RD by R to the power 4, which we can write Q by 4 pi epsilon naught into 4D by R cube. We know that the expression for electric field is, note down in rough this one, as we know that electric field is equals to 4 pi epsilon naught Q by 4RD, this one you need to note down, into R square minus D square. So from here we got is equals to, if D is very small than R, we can substitute the value Q by 4 pi epsilon naught into this one 4RD R square minus, if D is very small than R, so we can neglect D, minus 0 whole square. So it will be like this. This is the expression. Similarly, we can write where P is equals to Q into twice D. Here P is equals to Q into twice D. So we can write this one as, since we know that P is equals to Q into twice D, so we can write as here 2P by, how 2P? Because we know that P is equals to Q twice D, so like this you can write down rough work. So Q into twice D into 2, isn't it? So it will be like this. This one is P into 2, so it will be 2P. So 2P by 4 pi epsilon naught into R cube. This is the required expression. You need to note down. Now the next proof is, now how to find the expression for electric field due to an electric dipole at a point on its axial line. So first of all, for this also we need to draw a diagram on the axial line. This point is taken as A and this point is taken as B, and the electric field is applied here E1 and E2 at the point, and the point P is the dipole moment, and E1 E2 are the electric fields. Let us consider the origin as O, and the distance between A to O is D, and the distance between O to B is D. Then together this will be twice D, and the distance between O to P is taken as R. So we can write, let us consider now, let A and B, let A be an electric dipole at a point charges plus Q, at a point charges plus Q, this charges is plus Q, and this charges is minus Q, plus Q and minus Q. So let AB be an electric dipole at a point on the charges plus Q and minus Q. Then we can write separated by a small distance, separated by a small distance twice D. P is the point, is a point doing the axial line. Here P is a point doing the axial line of the dipole at a distance R, where P is a point on the axial line doing the axial line of the dipole at a distance R from the midpoint O of the electric dipole. Now consideration part is done. Now we need to prove. To prove, we need to write like this. Therefore, electric field at the point P. Now electric field at a point P, due to plus Q charge we need to find, an electric field at a point P due to minus Q charge we need to find. Then after finding this, we will come to know about the resultant electric field. So let us find P due to plus Q placed at B is, if plus Q charge, then we can write that E1 is equals to 1 by 4 pi epsilon naught into Q by R minus D whole square. The electric field, and here why we have written R minus D whole square, because look at the diagram, because look, from the distance between P and O, P to O is R, and the distance between B to O is D. So we need to subtract from R to D. That is why we have written R minus D whole square. Instead of this, here used to be R. Therefore, we can write now the electric field at the point P due to minus Q placed at A is, we have find out the electric field at a point P due to plus Q charge at the point B, and electric field at the point P due to minus Q we need to find now. So due to minus Q it will be E2 will be equals to 1 by 4 pi epsilon naught into Q. Now what shall we write here? This R is from P to O, R, then from O to A is D, so we need to add here R plus D square, because the distance between P to O is R and the distance between O to A is D, so that's why we need to add here. Now we need to find the resultant electric field. Since E1 and E2 act on opposite direction, they're acting along opposite direction, isn't it? This electric field is acting this side and this electric field is acting this side. Since they are acting on the opposite direction, we have resultant electric field. Therefore we can write E is equals to E1 plus, we need to add this two, isn't it? E1 plus, since they are acting on the opposite direction, now we need to write here minus of E2. Therefore we can write E is equals to 1 by 4 pi epsilon naught into E1, we can substitute. E1 is equals to this one we have taken common in both, okay, and this one we need to write here. So Q by R minus D whole square. This one also we can write minus of Q by R plus D whole square. Similarly, we can find like this as, which is equal to Q by 4 pi epsilon naught into, if we calculate both, if we find out the expression, then we can see that this Q by R minus D whole square minus Q by R plus D whole square, we can take Q common in both of these. So instead of this we took the Q common. Therefore we can write like this: R plus D whole square minus R minus D whole square by R minus D whole square plus, into R plus D whole square. How I have written this one as, I can show you in rough work. Suppose this one is the expression, isn't it? 1 by R minus D whole square minus 1 by R plus D whole square, and this side we have taken Q common, 4 pi epsilon naught. And if we take the LCM here, then what will be? If we took the LCM here, then it will be LCM of these two will be R minus D whole square into r plus d whole square, isn't it? Then after taking the LCM, we need to multiply it. We need to multiply this one. So r minus d whole square is there. So we need to write here r plus d whole square. And minus sign, negative sign is there, negative sign into it. And after that, r plus d whole square is there. So we need to write here r minus d whole square. R minus d whole square. After writing this one is into. So which is equal to q by 4 pi epsilon naught. Now we need to break out this one. A plus b whole square formula. R plus d whole square will be r square plus twice r d plus d square, and r minus d whole square will be r square minus twice r d plus d square, isn't it? Now this one also we can multiply this one, but for now no need. So instead of this, we put in the formula a minus b whole square into a plus b whole square will be equals to a square minus this one, look here, r minus d into r plus d. We know the formula, isn't it? A minus b into a plus b, which is equals to a square r square minus d square, isn't it? Now we can write here r square minus d square, and here the square is already there, so we can write here square. So next come q by 4 pi epsilon naught into, now r square plus twice rd plus d square, we need to cancel this one. R square plus twice rd plus d square minus r square plus twice rd, minus into minus will be plus, plus twice rd minus d square. So it will be r square minus d square by whole square. So which is can be written as q by 4 pi epsilon naught into, now this r square and plus r square and minus r square is cancelled, and here minus d square and plus d square is also cancelled. So instead of this we can write plus twice rd and plus twice rd. Twice rd plus twice rd will be equals to what? 4rd, isn't it? 4rd. This one is rough work. So it will be here 4rd by r square minus d square to the power whole square. This is the required expression, and we can substitute the value of p, since we know that since p is equals to q into twice d, we have already learned. Therefore we can write here q by 4 pi epsilon naught into, since it will be q is equals to p is equals to q twice d, so we can write here 2 into 2p. 2p p is equals to q twice d, so 2p we can write here 2p by r square minus d square. This is the required expression we need to find. This question may carry 3 marks. This question came for 3 marks in the last examination. Okay everyone, it is okay for today. And the next video I'll find the electric field due to an electric dipole at a point on the equatorial line. Please share and subscribe my channel to find all the notes and how to derive the formulas also. Please share and subscribe, and don't forget to like my channel. Thank you.